you very much for inviting me to the CSRBOX Summit. I'm sorry we've started a bit late, but hopefully there's enough time for us to catch up. So I'm going to sort of lead you through some of the AI aspects that are relevant in the education space, especially when it relates to public education at large in our country. But before I do that, I'll sort of do a brief introduction to some basic concepts in AI. Um, AI has become, sort of a catchword of late, and there's a lot of hype about it as well. Some of it justified, some of it not justified. So I hope I can sort of dispel some of the hype as well. Um, where should I be pointing this? Okay. So I'm going to start with some core concepts in artificial intelligence, talk a little bit about generative AI and large language models. You may have heard of these. I won't be able to do justice to any of these topics in the short time that we have. Then I'll talk about how AI can be deployed to create social impact, especially across the developing world, and what the applied aspects are, what the concerns are. And then I'll talk about AI in education, some applications, the work that we at Wadhwani AI are doing, and then end with a brief summary of challenges in the social impact space. So we'll start with the core concepts. Um, so AI is a branch of computer science that's concerned with enabling machines to perform tasks that were traditionally done by humans. It also has sort of a superhuman ability in the sense of discovering patterns within data that humans cannot easily discover. So there's two aspects of AI. One is automating what humans can do in a simple manner, but not in a routine manner, right? For example, recognizing if you talk about AI applications to self-driving cars, recognizing street signs is not a routine activity because every street sign is different, but AI can do it, right? On the other hand, there are very complex correlations within language, within large data sets that AI can uncover or see signals in that maybe us as humans cannot, right? And this is behind, for example, some of the superhuman abilities of AI to decode chest X-rays, sometimes better than radiologists, and so on. Right? Um, sorry, just go back. Where should I be pointing this pointer? Okay. Sorry. Okay. Okay. Um, Modern AI is driven by what's called machine learning, which is learning from data. And its machine learning comprises a set of methods used to train computers to learn from data. So AI wasn't always machine learning. In the old days, it was about things like recursive intelligence and so on. It wasn't about learning from data. But modern AI has largely come to mean learn from data. So essentially, the way humans learn from experience, AI learns from data that it's exposed to. So the analog of experience in the computer space is data. So I'm going to distinguish between what we call an algorithm in computer science and a machine learning model. So an algorithm is often a set procedure, a deterministic procedure, or a formula for solving a problem, or to conduct a sequence of actions. Whereas a machine learning model, as we call it, or an AI model, is actually an algorithm that has been learned by the computer. It's not been specified by a human, right? So that's the difference between traditional computer science and AI. In AI, the computer learns the algorithm from data. It learns a set of rules, which it understands, but humans cannot necessarily understand. Whereas in traditional machine learning, the humans specify the algorithm. So essentially, in machine learning, there is a process of training the AI, which is where you expose the AI to a certain data set. Um, excuse me, sorry about this. you expose the AI to a certain data set which consists of uh, raw data and known outcomes. What the computer system behind the machine learning method learns to do is to map the data to the known outcomes. And when it does this mapping, it sort of learned the algorithm. And this algorithm is then called the machine learning model. So now that you have, when you have a machine learning model ready, this is something that's been learned from data, you can use it by applying it to new data, and then it can make predictions on new data. So it's learned this mapping between data and predictions, and then when you expose it to new data, it can use that mapping to predict something. Right? And we'll get into more detail. Right? So again, traditional programming is you use your domain knowledge to create an algorithm. So a human creates the algorithm, um, and then the algorithm ingests a certain amount of data, and you get some kind of output. In machine learning, you have two parts: training and inference, as I've described. In the training part, the computer system is exposed both to the data and the output. It learns to map data to output, creates an ML model. The ML model is then used for what's called inference, which is actually using it in the field. Um, and it's exposed to new data. It uses the new data, uses the mapping that it's learned internally to make predictions. So I'll just briefly describe the kind of data that we're talking about. Data can be of many types. You can have, if we start from the bottom of the screen here, you can have text data. There's a lot of text data in the world, a lot of image data, audio data. You can even have tabular data in the form of Excel tables and so on. And the AI processes this data in different ways. There are various internal representations of the data in a computer system. Text is represented, for example, may be represented as 8-bit binary. Images are represented as a sequence of color values, color pixels on a screen, and so on. And then what is typically useful in AI models is also metadata. And metadata literally means data about data. So if you're doing, for all of you who are in the program space, doing surveys, collecting data, you know that it's not just enough to do a survey. You also have to collect data about the survey. When was the survey done? Who did the survey? Was there a quality check done? What was the location where the survey was done? All of this is metadata. And this is also useful in AI models. Of course, the reason I'm telling you all this is that data quality across all of these aspects is critical to good AI models. So if we want to move towards AI in many of our programs, it's very critical to have good data quality because the AI doesn't understand good data from bad data. It's garbage in and garbage out. So if you're using bad data, you will get bad AI models at the end. This is a thumb rule. So data, as I've already alluded to, consists of two parts. You have the features of the data, which has the specific properties or characteristics in a given set of data that can be analyzed for prediction. So in a sense, if you come from the world of statistics, the features are the independent variables of a data set. And a label is really the dependent variable or the outcome. The label is what you want to predict. What the AI learns is this mapping from features to labels. Okay? So, for example, this is a very simple model. This is not an AI model. In fact, I think when I've given this talk before, people have said, why do you need AI to do this? You don't need AI. This is just for an illustration. Let's say you have a set of symptoms about a patient and you want to predict whether the patient has COVID or not. Right? You want to assess whether the patient has COVID. Then you might look at a number of these features. So the slide is just to illustrate what are features and what is a label. So features are these characteristics of the patient, whether the patient has fever, cough, and sore throat, and so on. And then the label is the outcome. The outcome is COVID-19 positive, right? Similarly, if you have a different set of features, actually the same features but a different set of values for these features, you may have a different outcome. Now, if the AI is exposed to a lot of examples like this of features and outcomes, then it will learn to internally do this mapping between features and outcomes. And that's essentially what all AI models do. One second. Yeah. There's another branch of AI, which again you may have heard of, called deep learning, which is a subset of machine learning, where the AI attempts to mimic the complexity of the human brain. So it's based on what are called deep neural networks. They try to mimic the activity of neural networks in the human brain and try to learn the way a human brain learns. Of course, it's not the same. It's a very simplified representation of the human brain. Deep learning is a very simplified representation. It doesn't quite work the same way. So I think the best one can say is that it's brain inspired. So for example, when you expose a deep neural network to an image of a dog, for example, I'm not sure if that's a dog or a wolf, but an image like this, there are various layers in this deep neural network. These are layers of neurons. So these are not real neurons. These are simulated neurons on the computer, and they process this image of a dog by first dividing it into various sections, analyzing each section, and then merging different parts of the image together to create internal representations of complex structures within the image. And then based on those internal representations, then it can map to things that it has already seen before and match, right? Because it's learned this mapping from image, which is the features, to the label, which is the kind of image it is, right? So it's learned this mapping already. So it learns to correlate all these structures with the mappings that it's already learned internally, and then it outputs a probability. It tells you 90% chance this is a dog, 10% chance this is a wolf, for example. It's just an illustrative example, right? So this is how deep neural networks work. They don't just work on images, they can also be applied to text data, they can be applied to audio data, and so on. But the principles are similar. So there's something wrong with this. Okay. Yeah. Um, Next, I'd like to tell you a little bit about generative AI and LLMs, which has been all the craze lately. I think all of you know about ChatGPT and the revolution that started because of ChatGPT. Many students using ChatGPT for homeworks, for studying, for summarizing content, and so on. People using ChatGPT in all kinds of applications. But there's a huge social aspect to LLMs. You can summarize information in a simple way. Now, if you can summarize information in a simple way, that means you can reach the lowest denominator of society, right? And empower them with information. And if used in this way, LLMs are extremely powerful and a force for good, right? So I'll just briefly touch upon some aspects of generative AI and large language models. So there's two types of AI models, broadly speaking. There's what are called discriminative models and generative models. So discriminative model typically, as I've already alluded to, tries to classify a datum or predict something, right? And it's trained using labels and outcomes that are already known, right? On the other hand, a generative model, it tries to look at patterns within existing data sets and generate completely new data sets. So for example, if you think of ChatGPT generating a piece of text, the text is not something it's seen before ever, but it's seen patterns within millions and millions of sentences and words, and it knows something internally about how text is written, right? Just a generic idea of how text is written. It uses that generic concept to generate new reams of text, right? So that's generative AI. It's not at the back end, it's actually making a prediction. At each step, it makes a prediction of the next word in a sequence of words. But what it's actually doing as a result of that is it's generating new data sets. So I've already talked about this. So this is a class of models called generative models. There are generative models for images, where you can use AI to create image content, to create cartoons, etc., to even create realistic-looking photographs and so on, even videos, audio, and so on. And the principles are the same. You give it some input. For example, in a language model, you give it a text input, which is called a prompt. it produces a text output, but internally it also produces a numeric representation of text that's useful for other applications. So you can sort of chain this language model downstream to a host of other models to do various things. So that's really the power of these language models. So for example, by now there's various kinds of data modalities for language models where you input a piece of text. If you've used the latest version of ChatGPT, you know a little bit about this already. The output can be in various forms. So it can be text, and the text can do various things. It can translate, it can summarize, it can answer questions, it can correct grammatical errors. The output can also be an image. So if you give a piece of text, it can create an image that is described by the piece of text that you gave it, right? So it can generate images. It can also generate videos that correspond to the piece of text that you've written. Again, the accuracy is variable across all of these applications, but this is possible now. So for example, you can input a text that says, a man is running, right? And it should be able to generate a video of a person running just based on the videos that's already seen in the past. Similarly, it can output audio. You can do text to speech, which is an old application, but now enabled by LLMs and made more powerful by LLMs. It can now also output decisions, so it can play games if you ask it to play a game. Sorry, one slide back, please. Yeah. So various applications, it can be used for diagnosis and treatment prediction. For example, you can have symptom checkers based on LLMs that look at symptoms and then diagnose a disease. Chatbots is the obvious application. Most people use it as a chatbot. It can be used for documentation, creating documents, and generating new kinds of content, right? Various other applications. So why are LLMs so popular? Well, the naive answer to that question is now suddenly everybody knows about AI because of LLMs. There was this phase earlier where many people didn't know about AI when we didn't have LLMs, but now AI has become a buzzword. Even children know about it, mainly because they use ChatGPT or other similar platforms. But the real reason why this is so popular and this is such a powerful technology is because it's sort of a paradigm shift away from the old way of doing AI, which is that for every application, this is the way we used to do AI earlier, even at Wadhwani AI, every problem, every application had a different AI model, and we had to start from scratch. With these generative models and large language models, you have a core AI model, which is the large language model, and you can chain it to many other smaller models that are easy to develop to do various tasks. So for example, as already mentioned, if you want to do summarization, translation, question answering, these are 3 different tasks. In the old days, you would have to build 3 different models for these 3 tasks. Now you can just have a single core model, which is say GPT 3.5, and then have a small layer that is tacked on to it. Again, this is more of a technical thing, but it's a very simple thing to add on to a layer to do each of these 3 tasks. So it simplified the process of building AI models tremendously. So that's one aspect. The second aspect is what is called as the emergent property of large language models, which is that when you feed a lot of data into these large language models, they suddenly become very accurate at a certain point. It's almost like a phase transition. It's not like they gradually become more and more accurate. At a certain point, there is a huge jump in accuracy. So when I say accuracy, I mean complex tasks like reasoning. You don't expect, at least earlier, you never expected an AI to be able to do reasoning in the way a human would reason. So for example, you might say the air is humid today and so it's likely that it's going to rain. This type of reasoning was not possible by AI earlier. The more data you feed into these large language models, suddenly at some point you find that there is a jump in reasoning ability of the AI. So this is called an emergent property. Similarly, maths problems is something that AI couldn't do very well earlier, but the more data you feed into it, it turns out there's this huge jump in accuracy. If you look at these blue curves, that correspond to an increase in ability when you feed in an incremental amount of data. Similar with following instructions. There have been cases where people have used ChatGPT to write to create entire scientific arguments, to create hypotheses, give it a set of experiments, and it will generate a set of hypotheses. That is an example of reasoning that's only possible when you use a really large language model. You can't do this with smaller language models. So there are various limitations to this, obviously, and these limitations reflect even more strongly in the social sector in which we work. Um, there's bias. Bias is a huge problem with AI in general. Large language models just amplify this problem because they're trained on huge data sets. They inherit the biases of these data sets, and when they inherit biases, they do this in a super amplified way. So they tend to be much more biased than humans, just because they're much more powerful than humans at many of these things. So this is still an active area of research, mitigating bias. There are ways to do it. They don't always work for every problem. You have to experiment with different ways for different problems. Computational needs, this is not, unfortunately, not a very green technology. Training these models is compute heavy. It uses large amounts of electricity and large amounts of energy. Just keeping the servers cool when you're training these models is a daunting task. There's accuracy issues. Again, the accuracy issues go away when you use certain techniques like RAG and so on that I don't have time to get into, but these issues do exist. And there's input sensitivity. So the way you prompt, people who've used ChatGPT, for example, know that if you change the prompt to ChatGPT, the way you sort of seed ChatGPT or you jumpstart it, the output can change considerably, depending, on small changes here and there. So this is also a problem. This is called the input sensitivity problem. But by far the biggest issue with these large language models is the biases and how do you mitigate them. So now I'll get to the social impact space and where all this fits in, right? So this was sort of a very, very short and general introduction to what AI is and what the recent advances are. I'm sorry I can't do enough justice in the time that I have. But in the social impact space, we know about the Sustainable Development Goals. We know that the world is behind on the SDGs, and COVID and the Ukraine war has only exacerbated this issue. I don't know what the consequences of the Israel war are going to be. But if you just look at, so these are the SDGs sort of clustered by domains: society, economy, and environment. And then if you look at where we are falling behind, this is just a smattering of examples. This is not an exhaustive list. We're falling behind on education. Due to COVID-19, there have been school closures, dropouts, learning outcome proficiency is down by 20% pre-COVID versus post-COVID. This is across the world. This is not just in India. Increased inequities in education because of this. Poverty is up. 2020, the share of population living in extreme poverty rose for the first time in 2 decades, again, across the world. Food issues, there's low productivity of small-scale farmers. In low and middle-income countries, small farmer productivity is less than $15 a day. Worldwide average income of farmers, small-scale farmers again, less than $2,000 a year, even lower in countries like India, lower among women. Lots of issues there. So we know we're nowhere close to hitting these SDG targets by 2030. Disease, TB has just been sidetracked due to COVID. We know that as well in India. There's 10.6 million TB cases worldwide, roughly 30% of which are from India. So we've made very limited progress on the SDGs, and most SDGs are not on track to be reached by 2030. I mean, developing country targets are way off. So this is a problem. Where does AI fit in? So this is a sort of an old analysis by McKinsey. This analysis is already 5 years old and needs to be replicated. I don't think it's been replicated recently, where they analyzed mapping of AI methods to various SDGs. They looked at, how can you use AI towards various SDGs. They also did sort of an analysis, comparative analysis between the beneficial aspects of AI and the negative aspects of AI. Some of the negative aspects we know, lack of interpretability, bias, and so on. And the conclusion was that the positive aspects greatly overwhelm the negative impacts of AI. And it's a technology that should be used across the SDGs. A prerequisite to the technology is, of course, good data sets. And this is what, this is the biggest challenge at the moment. Sorry. So there's various facets of AI development. This is true for any sort of application, even more so true in the social impact space. You have to first start by defining the problem and asking, do you really need AI to solve this problem? And this is a question I think that's not asked often enough, especially because there's a lot of hype about the use of AI. People don't realize it's an expensive technology to develop. It's a brittle technology to use. And so it's not something that is a first solution to every problem. It really has to be the last solution. When nothing else works is when you use AI. You don't use AI if something else is working. Okay. So this is one thing to recognize. So it's very important to integrate this thinking into your problem definition. Does AI really work for this particular problem, or do I not really need it? I've already mentioned the importance of good quality data. Then there's a model building process that's sort of more of the science behind AI and machine learning that's done by data scientists. There's a lot of design research that needs to be done on the interface between the AI and the user of the AI. And especially, again, this is very important in social impact space where your beneficiaries, where the users of the AI are likely to be, are likely not to be technology savvy, right? They're not people who use technology regularly. So the interface they have to the technology has to be very well designed. The AI has to be evaluated periodically. As I mentioned, AI is a brittle technology. It's not something that you develop once and then forget about it. Deploy, forget about it. You can't do that because AI models don't retain the same accuracy over time. They drift, as it's called. They drift in accuracies. They need to be monitored regularly. They need to be replaced, refreshed, retrained with new data, and so on. Right? So this evaluation process in AI is even more important than any other type of technology. Right? Extremely important. Deployment considerations, there's many of them. If I have time, I'll talk about that a little bit. Even if you deploy it into your systems, can you drive adoption in social systems? This is a big question. You may have a technology that's deployed, but nobody will use it. This is a standard problem with technology in the social sector. And then monitoring and iteration is important. Again, I've already mentioned, scaling entails development of new technology often. So there's a few deployment considerations that are important. Pre-deployment, it's very important to assess the AI well and do what's called a passive evaluation, where you deploy the AI but don't act upon its recommendations. And that's how you evaluate whether it's doing the right thing. And then post-deployment, you have to monitor various metrics around the AI. And these metrics are not just usage metrics or latency metrics, also accuracy metrics. You have to watch for data drift, model drift, and so on. A very useful way of mitigating some of the biases in AI technologies is to have human in the loop, meaning that you use AI as an aid for humans rather than something that will supplant humans or replace them, right? And that's called human in the loop. And that often ensures that you mitigate biases in AI, but make humans more efficient. Sorry. We go one slide forward, please. Yeah. So developing these types of technologies often require highly interdisciplinary collaborations. This is sort of a figure of the kinds of people that we have at Wadhwani AI that we really need to build a good AI solution. You obviously need technologists, engineers, machine learning scientists, and so on, user researchers. You need domain experts who understand the problem space, program folks. You need buy-in, if you want to scale, you need buy-in from government ministries and officials, and of course you need buy-in from the implementers. There's in the NGO space in particular, you need buy-in from donors as well. It's extremely important, as we all know. I don't need to talk about that point further. You need to invest in building highly skilled teams. This is a very high skilled endeavor. So it's typically not something that happens in the NGO space. We are doing this, but there are various challenges. I mean, you need to employ extremely highly skilled people to do good AI. You need to invest in good data systems. This is again a challenge in the developing world. And then pick use cases very carefully. Right? And government role is especially important in strengthening some of these data systems and also in scaling. So let's talk. I'm going to spend the next 10 minutes or so talking about AI in education and some of the work we are doing. Um, Next slide, please. Yeah. So there's various examples, as you can already see from exposure to large language models and so on. AI can help personalize learning, where it can create, for example, syllabi or learning paths for students in a personalized manner. It can enable intelligent tutoring. Of course, automated assessment is one of the simpler aspects of doing things. It can create, you can use AI to create warning systems where you flag risky students in advance, students who are at risk of failing, students who are at risk of dropping out, and so on. You can use translation technology to do live translations. You may even improve accessibility through the use of AI for students who are disabled. And then it can help in administrative processes across schools. Some of the work we are doing at the moment, we've started work at Wadhwani AI in the education space relatively recently. So we are currently working on 3 projects at the moment. One is an oral reading fluency assessment tool that uses AI. The other is an early warning system for assessing students who are at risk of dropping off from school. Um, and the third is a report automation system for remedial interventions. And I'll talk about 2 of these, the oral reading fluency solution and the early warning system a little bit. The data sets that I used are speech recordings, school attendance data, and so on, demographic data of students, assessment data, etc. And currently, we are working with the Gujarat Education Department and integrating our solutions into the Gshala app that they're already using for their learning management systems. And our partners in this are the Gujarat government and UNICEF. So I'll start with oral reading fluency. Essentially, oral reading fluency is the ability to read with fluency. It's a very important indicator for learning new material, and it can be used as a foundation also, as I'll talk about, for improving learning outcomes. Um, so we've developed an AI tool called Vachan Samiksha, which can be used by parents and educators to assess oral reading fluency in children. Um, and and we've done a pilot for 20,000 students across Gujarat, and we are preparing to scale this up. Our goal is to assess 60 lakh students in Gujarat for reading in Gujarati and English, grades 3 to 8, up to 6 times a year. That's where we want to get to. So the way the tool works is that a student is given a piece of text to read. In Gujarat, this is done in Gujarati. I'm showing it here in Hindi. The tool at the back end works in various languages. The AI analyzes the way the student has read, and in particular, it looks at mistakes. So, so once the student finishes reading the paragraph, it flags where the student made mistakes in reading. It outputs a reading accuracy score. It measures the reading speed and gives an overall fluency score. Also identifies the keywords where the student struggled. And so you can imagine it's not just this is a very enabling technology, because it's not just this technology that's being used to assess students. In the back end, the technology is also collecting data on where students are faltering. And that data can be used to improve learning outcomes. Right? Um, there's a short demo. Can you please play the video? This is just a demo of the app, the way it works, I hope.
In a
Yeah,
garden.
so
It was
so this is
alone
in
and
English.
lonely.
A piece of text is provided to the student. Can we
One
turn up the
day a
volume?
bird came and sat on it. The
The
bird held
student
a
reads the piece of text.
bead in its beak. It dropped the seed near the tree. A small tree grew there. Soon there were many more plants. The big tree was happy.
And then the AI model analyzes the voice. Now, of course, this is sort of an easy example because very easy to see where the student went wrong. There are also much more subtle examples, but in this case, it outputs the percentage of correct words said by the student and
Pardon?
where it went wrong.
It was alone and lonely.
Yeah. Sorry, can you just pause there? Yeah. So it tells you the correct percentage, correct words per minute, which words were misread, and so on. And all this data is being collected across the state in the backend. It's done in an anonymized manner. It's not tagged to individual students, but it tells us by location where the issues are in terms of reading. Right? Can we go to the next slide, please? So it's flagged where it's incorrect. Yes. Next slide, please. Yeah. So this is what's happening under the hood with this model. This is sort of an architecture diagram of the AI. We first denoise the speech. There are a number of these deep learning based automatic speech recognition models in the backend. We have 4 or 5 different models in the backend that process the speech in parallel, and then a consensus decision is taken. And then what the models figure out is whether the student said a word correctly, which is called a hit, whether they misread a word and said it in a different way, which is called a substitution, whether they skipped the word, which is called a deletion, whether they said a new word in between, right, which is an insertion. And the AI measures all of this. And we have, so these are numbers for Gujarati. Our accuracies are pretty good across the board, as you can see. These are sort of the various metrics for accuracy that we use to track how well our model is doing. So this is the data from the pilot that we did. The next steps for this is obviously we want to scale this up and integrate with other states. We want to identify reading challenges based on the data we are collecting in the backend, because this is all automated, right? So all this data is automatically digital in the backend. We want to identify reading challenges by grade level, by location, by district, village, do root cause analysis of where the problems are, and try and address this through changes in curriculum and policy. I should also mention that the technology is insensitive to dialect. So if a student says the right word in a different dialect, the AI will actually flag that as the correct pronunciation and not as a wrong pronunciation. Um, so we really want to use this to improve learning outcomes. So we can, for example, use large language models to generate text at different difficulty levels. And thus, once we know what is difficult, the notion of difficult, which we'll know through this data, we can generate text at different difficulty levels and lead the student up the value ladder in terms of improving learning outcomes. The the other solution that we are actively working on at the moment is an early warning system for student dropouts. Student dropouts are a huge problem across the country, and there's no standard approach or intervention to prevent dropouts. There are various heuristic approaches that are used in different parts of the country. And of course, dropouts are a problem. It results in ineffective teaching methods and so on. And what we are working on is an AI-based early warning system that will tag whether a student is likely to drop out of school in the future, right? And we are leveraging data from, again, working with Gujarat State, leveraging data from their child tracking system and the applications that are integrated with it. So the first version of this AI model is more or less ready, where we've used student and attendance data, planning to hold a workshop with UNICEF this month, and a small pilot in Kutch and Banaskantha. The way this works, again, I'm running short of time, so I'll sort of speed up a little bit. There's various data sets that we use. We know the risk factors for student dropouts already. We use student data, school data, some parent and guardian data in terms of economic backgrounds, their demographic data, and so on. And then all this data is sort of fed into, it's cleaned up. We use statistical methods for data imputation and so on. And then all of this data is fed into an AI model. The output of the AI model is a probability of dropout score. So it scores every student based on their probability that they will drop out in the future of school. And then that can be used to drive interventions eventually. Again, these are our accuracies. We're doing, this is using two different data sets. One is, I think one doesn't have attendance data and one has attendance data. Uh, no, sorry, they both have school and attendance data, but these are two different AI models. And you can see the sensitivities and specificities are fairly high for predicting dropouts. So these are the sort of two things we are actively working on in the education space. And I want to end with some of the challenges that we face in developing specifically AI technology for social impact. Um, the data challenge I've already mentioned, and this is a huge challenge. This is why data sets need to be improved across the board if we want to use modern technology. We need clean data. We need data that is representative of the situation on the ground. We need big data sets, large amounts of data. We need a standardized way to label this data or to label outcomes associated with the data. There are privacy concerns that need to be addressed, and privacy concerns do exist even in the space in which we work. Even among the beneficiaries in which we work, they are very concerned about what happens to their data, what happens to their images, their audio, their video. That needs to be addressed. uh, we need to integrate different data sets across the country, and that's how we'll be able to derive value from them. There's huge time and resource challenges associated with the whole data activity. Um, Deployment, adoption, and impact come with their own set of challenges. It's preferable to integrate AI into public workflows than developing yet another app, because people are frankly tired of apps. And if you worked in the social sector, you know this, that there are just too many apps. Right? So it's best to integrate it to an app or a system that's being widely used rather than developing yet another app. Um, and then driving usability of the AI through training of the staff that will administer the technology. That's important. Doing this all at scale nationwide, this is another set of challenges. There are related challenges. You know, we don't have, in our country, we don't have AI ready thinking. We don't, you know, even among those who collect survey data sets, who collect all kinds of data, we don't have the mindset that this data may be used down the road, say 3 years down the road, for building an AI model or for building doing some very complex analysis. And so I better make sure that right now I have everything that I need when I'm collecting the data. So that AI ready thinking, even among government, is lacking. So we need to be able to drive AI maturity through government's ecosystems and leadership. Um, Once we deploy technology, we forget about it. We have this tendency, again, that doesn't work with AI. And finally, this not really a challenge, but really for us an aspirational model that how can we create a workforce across India that is able to build its own AI models. And there's a lot of technology being developed on how to easily, just with a few clicks, develop your own AI models, input data sets, not do any programming, no code technology where you can just develop your own AI models. And developing this ability across India is would be very inspiring. So I'd like to end there and take questions if there are any. I think.
You know, you talked of certain applications in the education space. Uh, can you share where they are in terms of commercial application, and if you, how far are we when like a school can go
Sorry,
somewhere
can you
and
speak up a little bit?
uh, you talked of application, six
Yeah,
applications.
yeah.
If you can talk about where we are on a commercial basis on those, and how far are we from when a school can go somewhere and pick something and start to use it in a cost effective manner for a school.
Yeah. So our work is not really commercial. We are a non-profit, and so at least till the pilot stage, our technologies are funded through external funders. I don't. So Google has some models that are commercial for education. I don't know how effective. I mean, again, it's something for Google to answer. But uh, one of the issues is how do you scale it up and make sure that these technologies are still commercially viable and yet useful to the lowest denominator? I don't have a very good answer for this. This is something that needs to be worked out because um, in other spaces like agriculture, for example, you can transfer costs to some of the fertilizer companies and the pesticide companies and deliver technology at no cost to the farmer. We'll have to come up with similar models for education. I don't see those models as existing. Maybe they do exist. I don't know about them, but models like that need to be developed because you can't expect people at the lowest denominator to pay for these solutions.
Good morning. Thank you for insightful session. And one question regarding, for example, you have shown two cases where AI can identify the problem, but what's about the correcting
Yeah.
it?
So that's what I was alluding to with the next step of this. So, for example, if the oral reading fluency solution that we have, you can use it in an automated manner to identify student difficulties. Now we are collecting all this data in the back end. So we will know student difficulties by location, by grade level across the state. Now with this, you can then, so you know where they're going wrong, what kinds of words, what kind of phrases are students finding it difficult to pronounce. Now you feed this data into a large language model and ask it to design a paragraph that is of a certain difficulty level because you know where the difficulties are. So it can take that as input and design various pieces of text at different difficulty levels, and then you can teach a student from those pieces of text.
Or can we think to integrate something where what is the wrong and what is the correct for it in the same
That
system?
we're already doing. That is
Already.
already integrated.
Okay.
It's
Thank
already
you.
showing that.
Thank
So
you.
then you can improve learning outcomes using it.
Thank you.
I think of somebody there. Yeah.
Hi. Thanks for the insightful presentation. I just had two questions, and I might have missed out on the beginning. Is there a particular grade that we are targeting? Is it only for primary school children or even beyond? Since the ASAR test, if I know correctly, is still grade 2,
This is
level
grade 3 to 8.
3 to 8. And are
Yes.
we planning to scale it up throughout till
For
grade 12?
now, for the oral reading fluency solution, yes. For our early warning system, actually the dropout problem is not so much at the primary level. It gets worse as you go up in grade. So there's a problem at middle school and there's an even worse problem in high school.
Yeah.
So for that, we're going to be targeting middle and high school.
Okay. And if I heard correctly, it's already being administered in Gujarat.
The oral reading fluency one, yes. We already
Okay.
did a pilot and we're planning to scale up now.
All right. How exactly is it administered? Is it at the classroom level? Does the teacher do it? Is there a particular
Yes, the
trained
teacher is
person?
doing it. At the moment, the teachers are doing it, not parents.
Okay, and they must be receiving some training for it.
There's not much training. It's already integrated into the Gshala app that the teachers have, and it's a separate feature on the app. So all they
Okay.
have to do is record, give the student a piece of text. It actually, I think, shows up on the mobile phone itself,
All
and they
right.
read it out,
Okay.
and that's it. It's just like recording. There's nothing else to be done, and then the AI gives the output.
Okay. All right. Thank you.